All right. So I guess, so this tutorial is really about, well, I guess I should say welcome to the first tutorial of 2021. Hopefully these tutorials won't be a disaster. This tutorial is basically continuing from 2020 and just basically moving on to actually trying to code the robot in more of an advanced kind of way. Like at first we basically just did basic code of like seeing if the sensors worked and see if we could drive the motors, but now we got to put it all together. And I'm going to do maybe 2, maybe 3 videos on it and kind of work from there. I apologize for the fan noise. My computer does not like the screen recording in its latest. But yeah, so I guess I should ask both of you guys what kind of setups you got in terms of Sumobots. Like, I'm going to do a tutorial on my bot, which has edge sensors, and I'm really curious if you guys are using photo-resistors or not, or if you're using the kind of like the crustier motors, like, not the crustier, but the larger motors. Using photoresistors, though I haven't gotten much done yet. Okay. So how much have you gotten done? Because sure, my bot's all built and assembled together, but really we're just like, you can definitely just have your motors all laid out. You can have your photoresistors all laid out. And that's okay too. All right, just still in the design phase, that's all right. Well, we'll still get it started, and you can definitely learn some Arduino code anyways, and of course this will be recorded and on YouTube for you to watch and rehearse. And so in the Slack chat, I posted like a giant block of code, and it's kind of just blank. It's exactly what this looks like. And this is basically like the base for a really, really simple Sumobot design. And if you have the PDF that I sent open, it has some basic drawings of kind of the logic that we're following. It's really, really simple. And yeah, and it also explains how you should assemble the photoresistor on your Sumobot, which is great. Yeah, this might help you. You probably see it already, but just put it up here. Basically, the idea is that an edge sensor, which is kind of like the fancier version, just has its own little LED built in and its own little sensor, and it outputs basically a 1 or a 0, and that's it. Pretty simple, like darker light, kind of like a little hairdryer, a little sensor on a hairdryer. And then your photoresistor, you're basically just making it yourself, and the photoresistor outputs an analog value because you're using one of the analog pins if you're following that tutorial. And you get a value, and of course we need to define what are these limits, and that makes it a little harder to control, but like not by much. And for reference, yeah, what's that?
I said okay, yeah.
Yeah, okay. And the Sumobot ring, for reference, is black in the center and white crisp little outside. And this is gonna be kind of important, I guess, to say. The logic, it looks complicated at first, but it's actually quite simple. I'm gonna focus more on the no ultrasonic sensor, so, you know, it's basically simple, go for it. If you see an edge, turn around, go for it again. It's not much more complicated than that, but of course we need to define each little bit. You following so far? So basically, I'm going to work through this kind of basics and kind of fill it out. So I kind of already got this loop here. Kind of fit right here. It's so simple. Go forward, if check edge, stop, turn around, and then it'll finish this block of code and it'll go back up to the top and then just go forward again. Simple. But of course, what I haven't defined yet is what counts as going backwards, what counts as going forwards. Well, in this case, we're not actually using go backwards, but what counts as going forward, what counts as stopping, what counts as, checking an edge, what counts, really. What does the robot do in those situations? So I'm going to basically go through, I'm going to use code from previous times and basically fill it out and kind of explain what's going on. Have you followed the motor driver tutorial, maybe, at least?
Yeah, I was here for all the tutorials.
I see. Okay. That means it'll be a little easier. It'll be definitely easy to follow, just to fill it out, basically. So I'm going to start, of course, with probably the easiest one, which is go forward. So these are functions here. So basically, every time the code gets to here, it'll just go up, quickly run the code, and then come back, and then continue going. And I've kind of set them up at the top because that's the way C likes it. They just like them at the top. If you want to do them at the bottom, you've got to do some other fancier stuff, and it just makes your coding a little easier. So I'm going to start with go forward, which is, of course, setting both motors to output in one direction. So in this case, I have the different pins here. So I'm going to do motor 1. Is this true? No, now I'm forgetting from last time, but basically you assume everything is set to 0 to begin with. I'm basically going to do that here, which I think I did already. Yeah, so basically everything's set to 0. Low is equal to 0. So basically everything's set up. We've done this with the motor tutorial. I've also set up the sensors, but we're going to talk about that later. Basically, we're going to just define go forward. What does go forward do? It turns motor A1 and B1 on. So it's basically motor B is the left, motor B is the right, or vice versa, can't remember. And then 1 is just like the direction. It's from that table from the previous tutorial. Basically, we're going to just define that. And then we're also going to define these ones as well, which is analog, right? And we're going to change these to 2 and 2. So this makes sure all the pins are set correctly when you set in the go forward command. Pretty straightforward. With the go backwards, we can actually fill that out. It's even so easy. We can just change that to 2, that to 2, that to 1, that to 1. And boom. If you call this command in your actual code, it'll just go backwards. Pretty straightforward. And then stop, even easier. Oh man. Can you guess this one?
Write the opposite values.
Close. You just turn
0.
Everything to 0. Bada bing, bada boom. These two are what we actually get fancy with. So since we got all forward, backwards, and we might actually, I'm going to experiment. I'm going to try and run the code actually and see what happens, but we might actually swap directions. Hopefully not. But turn around and check edge are where stuff gets fancy. I'm going to focus more on check edge at the moment, and then we'll go to turn around. Because that's going to be like a complicated list of go forward for this long, turn on this motor, turn on that motor kind of thing for so long. So check edge is basically, we actually need to read the output of the sensors, which in this case I've named them sense FL and sense FR, which is front left and front right. I have 2 sensors. technically I have 4, but I'm only going to use 2, and the actual 2 are on the corners. So basically I'm going to just do, if any of them senses an edge, immediately turn around. Just any kind of edge. Because it might come in at an angle, it might come in straight forward, we don't know, kind of thing. So basically it's as simple as an if statement, open that up, and it's basically, how do we know we're at an edge? Well, we do digital read. Oop, if I could spell. Digital read. No. Digital read syntax. I gotta quickly Google digital read. And then we put in the pin number, which is, in this case, just sensor FL. So this statement here is basically if digital read, and in this function here that is highlighted will either return true or false, and then the if statement will use that true or false to determine if it goes forward or not, or if it runs the code inside the brackets or not. So in this case, we want to do this or the front right. So what we're going to do is we're going to do a double kind of long bars inside the delete key, and then we're going to copy, paste, and then just change it to front right. So it's if this is high or this is high. In this case, I haven't even tested this either, which is high equals white, specifically on an edge. I haven't tested that yet, but we're going to find out. In worst case, we just have to flip it by adding an exclamation point here and an exclamation point there, and it'll just flip. Pretty simple. I could, go through the effort of looking it up and whatnot, but, experimenting is way more fun than that. So basically we're going to do check edge, and if so, we're going to do return true. And then otherwise it will return false. So that's another thing about C is these functions. So we have bool here. You notice all the other ones have void. Void will go backwards, void go forward. It basically says what gets returned. So when it goes back here, what does it return? If it's a void function, it returns nothing. It just doesn't return anything. But with this, I'm going to return true or false, in this case, which is a bool or a boolean. And C check edge is inside an if statement, and then the if statement's of course going to use that, like true, false. Does it go forward, or does it go through this code or not? And in this case, check edge is true, it will stop and then turn around. Very, very straightforward. So now that we got that working, I want to do actually, I'm debating if I should do some debug statements in here, but you know what? We'll find out. If stuff starts to go wrong, we can add those in later. So now, I'd probably actually like to test this.
Me?
Yeah.
Is that if statement necessary? Couldn't we just put digital read sense FL or digital read sense FR? We don't need the extra returns, just return the thing in the if statement.
Oh, this return here, you don't want it?
No, I mean like the thing in the if statement. That's Boolean type. Couldn't we just return that?
That is very true. That is a very simple way of doing it. Yeah, you can just take this and basically just return this. That is so true. Look at that. Return. Just like that. Simple. Easy. I still gotta warm up to code. I actually haven't written a lot of C code recently at all. I'll admit that.
What major are you in?
I'm in electrical engineering.
I'm in software.
Oh, but you're. You just started, or?
Second year.
I see. Are you finding it quite difficult, or what's up with that?
I'm pretty good with it. Honestly, co-op is what's taking my time and preventing me from doing much work on Sumobot.
Yes, applying for co-op. It is really difficult. A lot of people apply for like hundreds of jobs. It's very difficult, but definitely doing Sumobots, of course, is another thing to put on your resume, which is nice. Anyways, tutorial. Now I'm going to try and do the turnaround statement, which is quite straightforward. But of course, it requires a little bit of thinking. So what do we want to do, basically? I'm actually going to call the stop here, just more like redundancy, because maybe I just more insurance that the robot is stopped. What I'm going to do is I'm going to actually go backwards. So I got to think, what kind of path do I want to take? How do I see it? Can you see my camera, actually?
Yep.
I basically want to, like, do I want to just turn around on a dime? Sumobot's too big for this. Do I want to, like, just turn around on a dime and then go forward? Or do I want to, once it reaches an edge, back up a bit, turn around on a dime and go away? Or there's also the option of backing up, holding one wheel still, and then turning like this, kind of on a corner, and then going forward. And it's like, well, which one would be the best? And I'm still debating this as we speak, actually. And I'm thinking, prove me wrong here, but I'm thinking I should back up and turn on a dime, I think. Because I think if I turn like this, I might run into the edge again. And I think there's just a less likely chance if I just spin on this point here.
Yeah, so I agree with that.
Awesome. So that's what I'm going to try and implement on my code. So I'm going to go backwards. This is what the amazing thing about having these commands just kind of written out for you. It takes so little effort to actually write the code. Yeah. So go backwards, and then I'm going to do delay, because we're not getting fancy with more sensors. We're just going to use a simple delay. And I would say 1,000. I'd say go backwards for 1 second. 1 second or half a second.
I imagine if you'd want to get really precise on this, you'd have to measure the speed of the Sumobot.
Yes, and what's even more difficult is that what I learned doing Mindstorms and Lego whatever is that as the battery dies, that exact distance becomes a lot more difficult. So as the battery dies, basically time changes, right? The amount of how fast the motor spins changes, and how loaded the motor is. Is it running into an object? It changes that. So I guess if we had fancy rotary encoded motors, which are hella expensive, we could, but in this case, time. But you got the right train of thought there, definitely. Yeah. I mean, technically, I could actually just measure it, how fast the Sumobot actually moves. But I'm just going to go with trial and error, because I think in terms of time, it might actually be faster to develop. I'm going to go with almost half a second. Let's go with that. So we're going to go backwards, and then we're going to turn on a dime. So how we're going to do that is actually with manual. Oh yes, first of all, stop again after we go backwards, and then we're going to try and basically make one motor go in one direction and one motor go in the other direction. So I'm basically going to take this statement, which of course controls both motors in one statement. I'm going to turn 1 to 0 and the other one to 255. So motor B is going in one direction. Motor A is going in the other direction. So you kind of see that. So now that I think about it, technically it might actually go in the wrong direction, but it's trial and error because my wiring's a little weird and hard to follow, and we'll just see, basically. And it's also my own failure of not taking notes. I assume you probably are not going to take like meticulous notes. Again, it's a Sumobot, right? You can give it some leeway. So yeah, we're going to go, I'd say half a second. Because this doesn't matter too much. If it's too short, the Sumobot might just basically it might ride the edge of the circle, but kind of doing like little tangents along the circle and run around the outside instead of actually going and diving down the middle. If you can kind of visualize like a circle, maybe my camera, it might just ride the edge of the circle, kind of going forward around the circle. And that's the only issue with this delay. And we'll kind of see. I'm not actually going to run the Sumobot on the actual playfield. I'm going to more just like use a napkin or some kind of white piece of paper and see what happens when I cover the sensors. That's really the kind of the goal of this kind of tutorial, and then maybe we'll actually get fancier. Because definitely, like, nobody has like a Sumobot ring, right? And COVID or whatever. So it's kind of like the best idea to just do something that you can try yourself, which is, of course, a white piece of paper or something. So let's see here. I'm going to try and zoom didn't get in my way. Verify for one, see if there's any errors. Doesn't seem like there's any errors, which is great. And I'm going to try and plug in my Sumobot and program it. From previous tutorials, you probably know. Tools, Arduino Nano. We don't have a port selected just yet. We're going to select our serial. Let's see. First of all, there's no batteries on the Sumobot, so I'm just going to program it, and then I'm actually going to plug it into my power supply here to kind of demonstrate it. So let's see here. Verify. Done that, and then let's give it a shot. Done uploading. All right, let's give this a shot. This is an experiment. This is kind of nice. I have to see my own video eventually. Of course. Oh, that's right, it disappeared. Let's see here. I actually pressed the stop video button, I think. Here we go. So for me, I'm just gonna hook it up here. This is kind of just for experiments. Forward. Let's see. So it's going forward and stopping, which is interesting. It's very loud. Interesting why it would go forward and stop like that, but let's see if I put something wrong. But you know what? There you go. See, it's going forward. I have that white on there. And then I take it away. And it seems to be trying to do, it's actually going into this function here. But it doesn't, I don't think it's going into the, it's going, I don't think it's going to the right direction. It's going forward onto. Yeah, I got the forward and backwards direction mixed up there. There we go. So that tells us a lot. That simple experiment there, using just a basic, literally a napkin. For one, our forward and backwards directions are mixed up, definitely. So that's easy enough to change. Just take this, go forward, go backwards. Now it goes backwards. Simple enough. Verify that. But what that also defines is that white is what actually caused it to go forward, which we wanted the actual opposite of that. We've also mixed up that, so we're going to change it to that, or that. Which would that work? I think we want and here. You know what, we're going to leave it like that. Maybe we'll have some issues in the future. So now that's that. So now when I put the napkin in front, it should actually do its little beep boop bop kind of thing. Delay for like say 100. I'm gonna add some delays. I mean, it'll help us like figure out where it is in the cycle. I could start adding print statements and whatever, and it prints to the computer, but because that's a little more complicated there. I'm trying to keep this as simple as possible here. I'm gonna try and program it again. Pretty simple. Interesting. My video disables when I press program. It's hilarious. Probably because it's a USB camera. It's plugged into the same port hub as the Arduino. It's funny. Probably crashing the camera or something. Anyways, that's done programming. So let's see. Interesting. I think it works. It's very difficult to see on camera, but it basically, when I put the white napkin in front of the sensors, indicating an edge, it'll go straight forward. It'll stop. It'll go backwards a bit, which, to be honest, I think it's a little bit long. Let's change that to 500. It will turn, so the wheels will go in the opposite direction. I would love to run this with batteries. Maybe, if you want me to hook it up, I could. See what'll happen. The issue is I don't exactly have a switch on it, which makes it a little more difficult to control. But But yeah. Guess what's on the to-do list then? I think that's pretty good. That is pretty good. I think I might call it. I'm debating calling it here.
I'm
You know
fine
what?
with that.
I'm going to show you how to do the, I guess the, I'm going to adjust the, how would I say it? The check edge, so it actually works with the photo-resistors. That's a good one. That's what I want to do. So basically, I'm just going to comment button, just comment that out, and then copy, paste it, just uncomment it. We've done that after. And we're gonna check edge fancy function photo resistor. So it's of course slightly different because it's an analog value. So we're going to call it int value equals. So first we're going to, of course, fetch the value from the photoresistor. In this case, I'm just going to use both photoresistors as just an example. So I'm basically going to modify my entire program from start to finish just to use photoresistors. So I'm going to do analog green, if I can spell. Not. You write analog green, and then of course the pin. So I'm going to call it. Photo FL, and then FR. Pretty simple stuff. We're going to fetch the values, and then we're going to...
The variables are named the same thing. That is probably a problem.
Pardon?
Your variables are named the same.
Yeah, there we go. That should be value 2. Yes, you're correct. Thank you. So if define... Oops. Photo. In this case, I'm just doing arbitrary because technically my Sumobot's not going to run with this code, but I am going to show it here anyways. It's 83. And then we're going to, once again, comment that out. So now we have two variables. We've basically done a hashtag define again, which is like a find and replace, makes it easier to read. We can now comment that out. And basically put in, we're going to do like a comparison. So it's really hard to see what values the analog, of course, the analog photoresistor is going to get out, but in essence, I'm going to basically do an if statement if value 1 is less than or equal to 100. Yeah. The range usually ranges from like for super dark 200 and then for super bright 900. So let's say if value is less than 300, less than or equal to 300, or value 2 is kind of like the same range. So this assumes, of course, you have that document, this little document, you have your photoresistor kind of set up like that. Like that. If that, then, of course, return true. Otherwise, return Ball. And then of course we need to set, of course, pin mode down here. We gotta set that as photo FL down here. You can technically leave these uncommented and it won't really affect things as long as nothing else is plugged into those pins and you're not really using them anywhere else in your code.
I mean, commented out those constants, so.
Oh, that is true.
Kinda...
That is true. Yeah, so comment that out, and ta-da, we have photo-resistor code. Basically, we just have to worry about these now. So if I were to put the white napkin in front and it didn't do what I wanted to, or it did it kind of sporadically, we would adjust these values. And of course, if you actually had access to the little Sumobot ring, you would, since the reflectivity of the two materials are different, it's like a matte paint almost, then you of course adjust accordingly. And yeah, basically we got both versions. The ultrasonic kind of search kind of algorithm thing, I'm going to attempt to do that next week because I know a lot of people purchase them and kind of want to use them. So yeah, I think I can call it you then. Do you have any questions yourselves?
No.
Any questions about like 3D printing or anything like that?
No.
Do you actually plan on 3D printing or sending it out to us to 3D print?
I don't have any plans right now. I mean, I might, but I don't have any plans right now.
Okay. Well, it is totally free to 3D print, and we'll even do redos, I think, to a certain point, if you want. And then you just pick up from the North York address, and easy peasy. Safe drop, 3D printed to whatever your liking is. I'm basically doing the 3D printing. I've gotten pretty good at it too. Yeah.
If that's all.
Yeah?
Well, if that's all, then I guess bye.
All right, I can stop recording now.